Afternoon, everybody. So we're here to talk about Weave Ignite, and this will be kind of a general introduction to what Weave Ignite is, kind of the motivations behind why we built it, how we use it, and give you guys a few demos of us using it. So hopefully to ignite your interest in Ignite, if you will. So that's a pun, I just thought of that. Anyways. So I'm Mark Emeis, just a little bit about me. So happily married. I tend not to want to jump right in on all technology stuff, so I'll give you a little background on me. Happily married for 29 years. I got two fantastic children, neither of which became software engineers. That surprised me, but I'm an avid runner, biker, horror movie viewer. I'm a member of the SIG cluster lifecycle, mostly participating in meetings around cluster API. I'm the development manager at Weaveworks for a product called WKP, which is the Weave Kubernetes platform. Previous to Weaveworks, I actually was the founder of a company called Yippee.io. And Yippee.io, we had a couple booths at different KubeCons and DockerCons over the years. Some people may remember that, but that led me to landing at Weaveworks effectively when that got shut down. If you need to get a hold of me on Twitter, it's at Mark Emeis. On GitHub, I'm Pale Mountain Rider. And on LinkedIn, it's Mark-Emeis. So just a little bit about Weaveworks itself. So for those that aren't familiar with Weaveworks, we're one of the top contributors in the Kubernetes space. We've created several open source projects that you guys have either heard of or probably used, or if you're new to like GitOps, you're learning about it this week. But we kind of break it down into the Kubernetes space. If you're installing Kubernetes and you're using kubeadm, right, that is something that Weaveworks created early on in order to be one of the installers. If you're using EKS, you're probably using EKS Cuddle. That's another Weaveworks donation or open source project that we have. Way back in the beginning time of Kubernetes and Docker containers, there was something called WeaveNet, which was the original software-defined networking and firewall that was used by containers. And then we're talking about Weave Ignite in this space as well. On the observability front, so we have a product called Weave Cloud. We ingest tons of metrics that are Prometheus metrics, and we needed a scalable way on that, so we created Weave Cortex, which has scalable injectors and really a scalable version of Prometheus. That's in the CNCF. We have Weave Scope that's used for monitoring of Kubernetes, one of the top products, and we have almost 20,000 users of that. Getting to CD and the GitOps tooling, so you probably heard some about Flux. You may have heard a little bit about Argo and the combination of the two, but there's a CNCF project, Flux, that actually came from Weaveworks as well, and that's one of the premier GitOps technologies that you can use with your with your Kubernetes clusters. In addition to that, we have something called Flagger, so hopefully you've heard about that. That's kind of a progressive deployment tool in the GitOps space there. And as we're building these tools and working on the Weave Kubernetes platform, we work out how to do configs correctly and things like that. So we created another project called JK that allows you to keep kind of your definitions dry. So I'm just kind of giving a high-level overview. We have kubediff, we have cured. We have something for Grafana lib in order to capture your dashboards in a mechanism that you can create as code, and therefore you can version them and do all the things you want to do with those definitions, and all of that stuff is used in our WKP product that I'm not here to talk about. Kind of some recent stats that I pulled around the Weaveworks space. So we have almost 25,000 stars across our projects. We have 9,200 polls. We've had over 400 releases and almost 600 different contributors to all of the different open source projects we have. So if you have time and you want to investigate kind of what Weaveworks has to offer, which is a ton of things in the open source community, I encourage you to do so. But we're here to talk about Weave Ignite. So what is Weave Ignite? So I searched on Ignite, and there's a whole bunch of things out there, and none of them are related to exactly what Weave Ignite is. So Weave Ignite is an open source virtual machine manager leveraging the UX of Docker, container building blocks, has a built-in GitOps engine, and it was created by a VM agnostic company. So that's a mouthful, right? But we wanted to get across all of the different features that Weave Ignite provides you. And I'll be going through examples today and showing some demos of how that benefits you. You'll notice the Firecracker logo that's at the bottom of the screen here. So Firecracker is a micro-VM technology that Amazon released, and it has reduced the number of devices and the guest-facing functionality in order to reduce the footprint and provide more packable VMs that are quick to start up because it's used in Fargate and the Lambda functionality that Amazon uses. So when they open sourced that stuff, we had Lucas Käldström, who was in the Finnish military along with his buddy Dennis, and they needed a Kubernetes installation, and they needed virtual machines. They were very limited and strapped on cache. So they looked around, they found Firecracker, and they thought this would be a great technology to build on top of and use for the Kubernetes deployment. So interesting fact, I was just talking to Lucas, that first version that they developed is a 500-line bash script. So, you know, it may be fairly fragile. But anyways, when they got out of their Finnish military duty, they actually came to Weaveworks, and they re-implemented it, and that's what we're going to talk about today. That is Weave Ignite. So when I think about running workloads historically and over the years, in my mind, I kind of think of 5 axes of those workloads and the benefits we get from the different layers that we could use to run those on. So if we start with hardware and operating system, just a base hardware and installing an operating system on there, the 5 kind of axes that I think about are simplicity, security, performance, flexibility, and utilization. So when we had hardware and operating systems, we had pretty simple because that was all you had, right? You could take advantage of that. Performance, you had the entire machine for you to use, so you had as much performance. And security was, yep, I'm gonna run the workload on this one machine and operating system, so it was as secure as the operating system as you could make it, but you weren't worrying about competing processes and stuff like that. This started to break down in my mind when some of you will remember Moore's Law, although I think it's not as relevant now, but there was a time when the number of transistors in a CPU were doubling every 2 years, right? And so what was happening is we were creating this hardware that had massive capacity, and we couldn't take advantage of it, nearly as much of it as we wanted to. The other thing that was kind of an issue on hardware, and this is more on the Microsoft side, some of you may remember something that was affectionately referred to as DLL hell, and that was where you tried to run a Microsoft process that used dynamic link libraries. I see some nods in the audience, that used dynamic link libraries, and yeah, you could run one and then you'd install the other one and the first one wouldn't work and the second one would. You'd install a third, neither of them would work because you would have all these conflicts on the DLL stuff. So things like OSGI were invented. Actually, that was more for Java side of the house, but different things were invented to try and address that shared nature of wanting to take advantage of this bigger, beefier hardware, and we couldn't do it. So enter virtual machines. So when those got added into the equation, right, your utilization went up because our processors are getting there, and I can run multiple versions of an operating system on there with workloads that would have some, good security and isolation in it. The flexibility was there, so now all of a sudden on my Windows laptop, I can run different versions of Linux. I can run on a Linux box, different versions of Linux, and I could do more flexible things that I couldn't do previous when I had hardware and operating systems. Enter containers. The container space that I'm talking about here is when we had namespaces and C groups, so just the bare building blocks are there. So now utilization even doubled because, well, we're sharing the processor, we're sharing the operating system because we're running just as processes. We have great flexibility in that. We have really good performance, but we kind of lost the simplicity and the security layer. Enter Docker. Docker added in the simplicity layer, and really once Docker came in, the simplicity skyrocketed, and that's when we really got to see the utilization of the container technology over time. But we still have that security axis that is missing. So enter Ignite. So again, this is how I think about things. So I got the 5 axes. We enter Ignite with the container utilization or the container-centric view of things, and it kind of rounds out our picture here a little bit. So we're going to add back in security because we're going to leverage Firecracker with the KVM and CPU level virtualization. We're going to have all the benefits of the containerization work that we've been all learning on Docker as we move forward. So I kind of see it as a nice rounding out of the picture, if you will. So Then we saw John Wick sitting out in New York City somewhere, and he was wondering thinking, if only I could manage my VMs as easily as I could containers, right? And this is sad Keanu Reeves thinking that. So what Lucas and Dennis put together is they thought, sure, we should be able to do that, right? So this is the CLI command for Ignite. And if you take a look here, you'll see that a lot of these commands, they should seem familiar to you for those of you using Docker. So things like attach, start, stop, exec, right, inspect, those are kind of things. So we wanted to take a UX that was well known and transition that to be able to utilize on virtual machines as well. So we took that and we thought that was a good addition, right? No need to reinvent the wheel here, especially when we want to leverage that UX that we had on Docker, right? So as I go through the presentation here, not only did we do that on that level, but we wanted to leverage even more of the Docker and the container aspects for virtual machines. And so you can actually take a Docker container, if it has an init process in it and systemd in it, you can run that on Ignite just like you can as a Docker container. And so that's really where the power is going to start to come in, and I'll show more about that shortly. So when I started writing the presentation and thinking about, what was our motivation, what were some of the things that we looked for in an environment, why did we look for these sorts of things? And so these are kind of the ones I landed on. So we wanted to have an open source virtual machine and a VMM solution that we could use. We wanted to be open source because if we run into problems, we want to be able to adjust it and make it work the way we need to do it and give it back. Again, Weaveworks, huge open source community, our contributor, and so we wanted to leverage that as well. We are the GitOps company, so we needed to have declarative control. So we all have religion around GitOps inside of Weaveworks to where we know, yeah, I want to capture the facts of what I want, and then I want to have a separate process that goes ahead and makes the facts reality. So the declarative control is what's important there. And of course, all of us using Kubernetes, we're already used to that, to where we do a kube control apply, and then it just makes it, it's kind of, we used to call it goal seeking before there was Kubernetes, but it's kind of that process that says, that's what they want, I'm going to do what I need to arrive at that situation that was defined there. So sometimes you have limited access to cloud resources. This could be money. So you can't spin up 50 machines out in the cloud because you can't afford it, or maybe you have limited networking bandwidth, and so that would be another motivation here. One of the key ones for us is we wanted to have faster test around time. We tried Docker and Docker with something called Footloose, another open source project from Weaveworks that you can take a look at, but it basically put VMs inside of containers. So you would start up, do a Docker run basically on an Ubuntu image, and it would run inside of a Docker container. But we ran into issues when we started to do nested containerization inside those objects, right? Because they would be a sibling to the Docker container instead of nested inside of it. And then finally in this area, around non-functional requirements testing. So years ago, I worked on a project called Skynet. Usually when I tell people that, they have all also worked. Has anybody else here worked on a project called Skynet? Just curious. Nope? Okay. Yeah, for those older Terminator fans like me. But anyways, so we had this project called Skynet, and what it would allow you to do is you would take a rack of hardware, you would network it together. When it requested an IP address, we would image that box, we would put that imaged machine into a cluster and build up these large clusters from all of this rack hardware. So this was prior to Kubernetes. And one of the things we wanted to test is, well, how does it work if we have a large number of machines? And then more importantly, what happens if we have a catastrophic outage? So we started looking around. Very difficult to test something like that because at the time it was all testing with real hardware. We were able to create a Xen-based solution and test it that way. And so the things we learned from that, I learned from that, was being able to simulate a catastrophic failure, being able to do chaos monkey testing and stuff like that in a quick enough fashion to where you know that your software is doing the right thing with quick turnaround time. So that was a huge motivation around Ignite as well here. I mentioned a little bit before about embracing container management. We want that disposable infrastructure. We want immutable infrastructure for your virtual machines. All of us are still, I think, hugging on a little too much on virtual machines. I know I am, because I'm going to use one in my demo here shortly. But yeah, we want to get away from that. So if they're easy to create, easy to reproduce, you can create them as more disposable resources. That's all better. We want to leverage container runtime, CNI benefits. And again, I said the VM and pet mentality. So we're going to hop to a demo real quick here, and I just wanted to put out a few of the requirements that you have to have in your host operating system. This is up on the website, but you need a 4.14 kernel, IPv forwarding. The key ones here would be the CPU virtualization, because we're going to leverage KVM and the CPU virtualization that's in there in order to run the Firecracker VMs. In there. There is no ARM support yet, but it's in process. And Lucas, who I mentioned earlier, who created most of this technology, he is actually working on Raspberry Pis to be able to run Firecracker VMs and using Ignite to do that. And I think he got that submitted just recently. So we do have ARM now. So Lee is one of the maintainers of Ignite, by the way, in the front here. No support. Okay. Then you're going to need a container runtime. So if you're using the latest version, it's containerd or it's Docker. You need CNI, Git, OpenSSH client, device mapper, KVM. Again, it's all listed out there. I just wanted to cover it before we jump to a demo. So you need a KVM, and you're going to need Ignite and Ignite D, depending on how you want to use it. So with that, I'm going to jump to a demo here real quick. So hopefully, I knew that was going to happen. So sitting on a machine here, I've split my screen here. At the top is basically just querying to say, what Ignite machines do I have? Nothing's listed there. And in the bottom, I'm going to do some Ignite work here. So we'll just go ahead and do the Ignite before, because the help actually gives you a nice listing of what it would take to run an Ignite machine. So there's the command line if you wanted to just spin up a machine. Ignite run. Weaveworks /Ignite-Ubuntu, so that is a Docker image out on Docker Hub. I'm saying I want to give it 2 CPUs, 2 gigabytes of RAM, turn on SSH, and name that VM my VM. So we're going to go ahead. I didn't want to do that because that's just running one VM, so I wanted to show a little bit different way to do it. So I just went ahead and wrote this little for loop that's going to do 5 VMs, all with different operating systems. And we're just going to start those up. So again, to reiterate, I'm on a Mac here. I'm running VMware Fusion. So performance is going to be quite a bit different than if you're running natively on Linux. But you can see, before I finish talking, I got all 5 of my VMs up and running. And you can see that I have an Ubuntu VM, I have an Amazon Linux VM, I have a BusyBox VM, an Alpine VM, and a CentOS VM. So, and that was just a simple for loop. All those are Docker images off of Docker Hub that run. So I'm going to go ahead and attach to one of them. So I'll just attach to the CentOS machine here. So you can see that the CentOS Linux was fully available up and ready in 2.8 seconds on here. And the actual hardware for the VM before we started putting CentOS on it was a second and a half. So that's VMware Fusion running on a Mac with nested virtualization turned on so that it simulates all of the hardware there. If you read the Firecracker website, they talk about running 4,000 machines, and all of them, I think, are sub-second start time. Lee, is that right? Yeah, so sub-second start time. So now, okay, my VMs are coming up fast enough, right, to where they're mirroring what I could do with Docker containers, only it's a full VM. So as I mentioned before, I attached to this machine here, so we can go ahead and log in, right? And so now we can, cat proc CPU info, and yeah, so this is the virtual machine that I just started up. You can see in there, I said it only needs 1 CPU. If we wanted to cat mem info, again, so I said half a gig of RAM, there's half a gig of RAM there. And if I do a uname -a, you can see it's a 419 kernel. If I log back out and I do a uname -a on my Linux box, or my Linux VM, it's a 5 kernel. So I was able to start all those virtual machines with one command, a for loop, which looked just like a Docker command. It downloaded the image, so it was fast. I downloaded the images previously, right? So we're using a container runtime, so that is caching the images for me, and that's why performance looked like that. If I had to download the images across the Wi-Fi here, might not have been quite as fast. And then to show you, how easily it is to then clean up, I'll just go ahead and hit the remove of the VMs, and that's it. They're gone, right? So simple commands, in and out, starting, stopping, but getting a whole virtual machine in that short amount of time is what I just ran through there quickly. So that was the first demo of just creating a handful of VMs. You can see how if I could create that many on a virtual machine running on my Mac, if I had a regular machine, I could do quite a bit more with it, especially like when I want to do chaos monkey testing or that sort of thing. So what happened? It looked easy, but there's a lot of stuff happening under the covers here. So this is, I tried to put together this sequence diagram to kind of understand exactly what really transpired, right, that we just did. So I did Ignite run, what happened? When I did that, it talked to the container runtime. In this instance, it was container D. That interacted with the image registry in order to pull down the image, cache it down. We then turned that image into something that could be used by the device mapper to use as a root file system for a virtual machine. So then we set up a network using CNI networking. Then we interacted with the container runtime. Again, in this case, it's just container D. And we said run this process, or run this container that has two processes in it. It's an Ignite spawn process and a Firecracker process. So this would be the Firecracker thing that started the VMs in KVM. So Ignite spawn interacted with Firecracker, who interacted with KVM, who generated a virtual machine. Again, that's that stripped down virtual machine on KVM that in turn used the root file system that we set up with the device mapper. It DHCP'd, the Ignite spawn process took its IP address that it got from CNI and gave it to the VM. So now that VM is routable and available, and you saw the IP addresses listed on the machine there. So kind of a high-level review that there's a lot of stuff going on underneath the covers to do that, but the key point was trying to simplify it all down to where it looks like you're just running containers, right? And so we're going to continue on that theme as we go along. So this is just another picture of the architecture and the kind of the breakup of what happened there. So there, we started out saying we needed to get the OCI images. So if you were to do these steps, so run encapsulates all of these steps. But you can do these individually so that you could like cache images and things on your own. So I did an Ignite image import, or we did underneath the covers. That generated these write-only snapshots using the device mapper. We started this OCI container that you can see listed here, where the first process is that Ignite spawn that created the Firecracker, and then that created our KVM, we assigned the IP address, and poof, we have some VMs there. So OCI is a great standard, and we thought, why not reuse that for here? So we're using that for content distribution, some monitoring of processes, and process isolation. So this one seems weird to me when I look at that, because I think, okay, we have KVM and we have virtual machines running in KVM. Why do I have a container there that matches it? So the container's there for a couple of reasons. One, if you were to break out of your virtual machine and you could get access to the host and get access to Firecracker, okay, you kind of got the keys to the kingdom, right? And you can mess with everybody else. If we use containerization in a Docker container to have Firecracker there, well, now you're going to have to, you could break out of that, get into the Firecracker container, but now you're going to have to break out of the container that Docker gave us or your container runtime in order to do any kind of damage to any of the other containers. Not to mention we use the networking and things that we get from Docker in order to facilitate a lot of the networking stuff and simplify it down. So that's why we have the containers there for that. In addition, we use the resource limit. So if you were to specify different resource limits, we put those on the container because it already has that mechanism to do that work for us. So we're using device mapper and DCP bridges, like I mentioned, and that's kind of the high-level architecture of what happened when I hit Ignite run. So let's talk briefly about GitOps. Hopefully, everybody's heard of GitOps and knows a little bit of something about it, but if you don't, that's okay too. So GitOps is really separating the what from the how, right? So you want to capture your facts, put them in your repository Git in this instance. It doesn't have to be Git, but you know, that's kind of where we started. So we're saying GitOps in that, but really it's you know, capturing your facts and using it there. So and that's your single source of record. And then you have a separate process that is working to achieve those goals, right? To achieve that setup. So we have this loop in here that says, okay, you get your state in Git, you release that, it goes into your runtime system. You observe what the system's doing based on that. You diff based on desired state versus the actual state, trying to figure out, do these match? If they don't, I need to take corrective action. So should all seem familiar. Kubernetes is like that in a declarative manner. And then this loop just kind of goes around. So the key is really that reconciliation loop. You could do a lot of this with imperative work, but what are you going to build? You're going to have to build a reentrant and an idempotent shell script that you can run on cron every X amount of time. And you could absolutely do that. We've all probably done that as we're adopting these kind of things, but it makes it really difficult to know where it failed, why it failed, what's the difference here. So when you can diff the facts in the repository versus what the observable state is, it makes things easier there. So then I mentioned here about the common tooling. So a lot of people, you know, we say GitOps and they think, okay, well, everybody's just going to use Git. And it's really, with the invent of Ignite and how we've put it together, now we want to make more of the tooling common across both dev and ops. So as a developer, right, you're containerizing your workloads and you're building microservice applications using containers, et cetera. If now I can build my virtual machines the same way using Docker build and Docker containers and store them as OCI images in the container registries that we already have, leverage all of that infrastructure, that all seems like a win. And that's what we mean by you're sharing that same tooling across those environments. So I grabbed one of the manifests from one of my VMs as I was testing. So this is just a GitOps an Ignite inspect. And you can see here it really breaks down into 4 different blocks. And again, hopefully you're getting a theme here. Again, this should look familiar, right? Because we're leveraging the Kubernetes API machinery in order to deal with manifests. Right? So here we have a kind. So what is this? It's a virtual machine. How do I identify it? What's my metadata? Basically, because I need to identify it both in Git and I need to identify it in the running system. And then what's its definition? So it's spec in that. So I have 1 CPU. I want 4 gigabytes of disk space. What's the image I'm going to run? So my root file system in this instance is Ignite Ubuntu latest. And so building on that, and then finally we need to have the status. So basically tell us when you observe the state between what it is and what it, or when you observe the state of what it is, we'd like that recorded here. So that's in the status area. So all of this should seem very, very familiar for everybody that's working with Kubernetes because we leveraged a lot of that same infrastructure here. So we capture the definition of what we want. We just need the how we make that happen. So I'm going to do a demo now of the GitOps processing that Ignite provides for itself, but really Ignite can be leveraged for other GitOps processes that you need to isolate and do repeatable processes in your environments where you need a virtual machine and maybe multiple different OSs in your environments. But this is the GitOps specific attributes that Ignite provides here. So back to our same machine here. So what I have created is I have a Git repo out here in my account, and it has 4 machines defined in it. So, and these should look very familiar because that's what we just had up there. But the key point here is I've set all these to running as false. So basically what I want is when I start the Ignite process, I want you to prepare to run these. And then at a later date, we'll go ahead and turn them on or off depending on it. So if you were doing testing, maybe you're doing Ubuntu testing and you need to spin up 5 Ubuntu machines and you want to leave the CentOS machines ready to go, right? Even though it's fast enough to start them up, it's even faster if you can cache some of the images and be ready to actually start them up and run. So I'm just going to start the backend process, which is Ignite D GetOps here. So if I take a look, I'm running Ignite D GetOps. I have my repo here that I've set up keys so that I can pull from it. I have log levels set to debug. Maybe I won't need to talk about that, but I have it set for that now. So what this is going to do, it's going to start up some reconciliation loops, and it's going to query my repository to see if there's any work that it needs to be done. So this takes just a little bit here. So it's initialized, it's pulled the repository, and let's see what it does here. So it noticed that I had 4 machines defined in there. It created all 4 machines, and they're there. I have that -A flag on my Ignite command line for PS, which says show me everything. And you'll notice all of these are listed as stopped right now. So they don't have IP addresses. They're not taking any resources right now. When you carry through with GitOps, or it's also sometimes referred to as a pull request mechanism, and that's how I like to do it. So I've created a pull request out here that says turn the machines on. So we went through all the testing and everything, and if we take a look at the change request, all I did was change it from false to true. So I'm going to hit merge this pull request. And now what's going to happen is Ignite's going to see that change, and it's going to turn on all these machines, give them IP addresses, and make them ready for whatever I'm intending to use these guys for. So, and now you can see why I have debug turned on, because I turned all the machines on, but for some reason it didn't turn on the last machine. Booted everything but the last one. I was talking to Lee earlier about this. So this is all still in active development. It's a live demo, and unfortunately, this has worked for 2 weeks until last night when it stopped working on my machine. But so what did I do there? I didn't touch anything other than make a pull request and have Ignite go off and do that. So by capturing all of the definition of your environment, testing and everything, you can give it to multiple developers. They can work on that. They can spin up these virtual machines on their desktop to run whatever testing they need to do in their area. So that's it for the Ignite DevOps processing there. So I'll hop back here. Don't worry, I know I'm standing between your party tonight and enjoyment. So I talked about the fact that we're leveraging as much as we can as far as the Docker aspect. So when you guys build virtual machines today, do you go to, depending on which machine you're using, you're probably building a VMDK and you're provisioning a certain amount of disk space, and you're running an installer and doing et cetera work in there to get that VMDK ready to go. 3 minutes? Okay, I could speak faster. Anyways, so what you see here, these should look familiar too. Again, that common theme. But we're building VMs the new way by building Docker containers. So these are Docker build files. The one on the left that you see is a kernel. And the one on the right is the Ubuntu machine that we ran in the demos here. So these now I have code, they're Docker files. I do Docker builds, check those into a Docker registry, and then run them with Ignite. So last quick demo that I have, and that is that Ignite produces Prometheus data. So since we're using containers, we can take advantage of all of that infrastructure as well. So I'm going to switch back over here, and unfortunately, we're going to go ahead and kill this one. So we opened a socket. For each virtual machine that's there, it gets a socket that is the Prometheus data, and also the Ignite D process has a socket that will tell us details of what it's doing. So if we take a look here, I just queried the Ignite daemon to see, and I'm grepping out what VM operations it did. And you can see that it said I created 3 machines and I went ahead and started 3 machines. And if I had queried that in between the start, or setting that definition from running false to running true, you would have seen that it only created 3, and then it started the other 3. The bug I'm trying to find is why it didn't do 4, but it's a demo, so I kind of expected something to not work. And like I said, we can also query each of the machines themselves. So if I can spell. So If we take a look at one of the IPs there, or one of the IDs of this machine, and we can query that socket, and we can't connect to that one either. So that's probably the one that did not start up. So it's a demo. I apologize for that. Basically the end here, we'd like you to get involved, typo intentional. So we'd like to see people, building other Kubernetes distributions on here. So one of the things that we did is we created something called Firecube at Weaveworks. It's all open source, and what it does is it uses our WKS control that's open source, uses the footloose process, and then creates virtual machines using Ignite underneath that. So you can scale up and scale out clusters from within Kubernetes using the Firecube technology. So yeah, we could use help in all sorts of areas. It's a typical open source project. Please go in there and get involved. And yeah, you'll probably see myself or Lee here approving pull requests and whatnot on. And if you want to learn more about GitOps, we have a hands-on demo that you can do and get one of these nice shirts that Lee is actually wearing. So with that, I'll take any questions. Am I over time?
Yeah, you're good.
Okay.
It's the end of the session. Oh, sorry, it's the last session. So ask as many questions as you want. It's just whenever you would like to be done.
Yes.
Can this support non-Linux OSs? It's a VM.
The reason is because Firecracker, the reason it's so fast on boot is it does Linux boot stuff in memory. Does that make sense? That's the short answer. Is no.
Yep.
The entire reason containers use Linux is because they share the kernel with Firecracker.
Oh, we need to do the mic, Chris.
I guess expanding on that, isn't the entire point of Firecracker that it doesn't share the kernel,
Yes.
but it still relies on Linux?
Yeah, so basically the way that Firecracker boots machines, it specifically boots Linux. So Firecracker cannot boot Windows. Some folks from Solo 5 and some unikernel type projects looked at booting Firecracker with unikernels. So that would work. But as far as booting Windows, that's not something that Firecracker supports.
So I'm not sure, maybe I misinterpreted your question, but I think it was along the lines of, can we run Ignite on our Macs without needing, was that? Okay.
Yeah, booting
so
a Windows guest is not supported, but some folks looked at unikernel guests.
Okay.
Yeah.
I have a question.
You got the mic.
Okay, where's Mike? Who's Mike? Is the goal to make Ignite fully analogous with Docker? In other words, I can do Docker logs to provide that same level of adoption and simplicity.
Yes, it is, but what we really need is more community involvement to help us drive what are the most important things to focus on. So we don't have an overarching goal to say we want to mimic everything we do in Docker in Ignite. We're looking for involvement from the community to help us decide what's the most important thing to build.
So, and then flipping the guest OSs, when can we expect this to be able to run on Mac, at least personally, Mac, or Windows, I guess, for Windows people?
I think, right now, at least on the Mac, it doesn't support nested virtualization in the operating system itself. So we can't have KVM on the Mac today without a virtualization layer.
Okay.
So if OS X opens up and gives us nested virtualization, I think then we'd be home free.
And then one final question, because this is KubeCon. There are tools like telepresence and such that are used, scaffolding, all these tools, Istio. Take telepresence, for example. Will that work with Ignite and Firecracker running on a Kubernetes cluster? And if not, what will that take? Because I know you mentioned there's a container wrapper around it.
I don't know the answer to that.
So
Lee?
for something like Istio, it's definitely not.
Actually, let me throw something in there. We have used Ignite to build nodes that we then use in our Kubernetes cluster. So Kubernetes just sees them as nodes in our example. So it wouldn't interfere with the use of the containers if I'm thinking of the question right.
Yeah, running Ignite VMs on a Kubernetes cluster is something that is technically feasible, and that one of our primary maintainers is very interested in writing a virtual kubelet plugin or implementation to support. And then when that is happening, one thing that is very important, did we touch on the fact that networking is provided by CNI?
Yeah.
Right, so yeah, like you can put a bunch of Ignite VMs on a WeaveNet or a Calico, and it'll work with things like Linkerd as long as there's not too many crazy IP table stuff that are making things not work. There may be like some abstractions that are not fully workable, but we'd have to look at it. Yeah. If you want to use something, right, like let's go make it work. So this project is like, let's totally do cool stuff together, not like, oh, this is important for production on 5,000 servers. There's a question back there if we could get a mic to them.
Where does the kernel come from?
Kernel comes from a Docker image, and it's built, and you can provide your own. Yeah, the rootfs is expanded.
We got one more.
So Docker kernel is actually this build file, and it's in the repository. If you
Yeah, one more question.
Yep, one more question.
Continuation of the same Docker file?
No,
Two separate ones.
two separate build files.
Yeah, the kernel is one image, and the rootfs is the other image for the actual. So you can swap the kernel out.
Right.
What's this guy has a question?
Yeah.
So yeah.
It's okay, sorry. Really cool technology. I love what you guys have done. I'm thinking though, in terms of who your target audience is from a business value perspective, like as a, to this guy's point, like as a Mac user, Docker desktop is way more convenient because, I want to develop with Docker and it just works on a Mac out of the box, right? Sandboxed containers, sandboxed pods, are great for security, right? Because that's what a lot of people want to use them for, which is typically more a production use case. So I'm just curious if you can speak a little bit to the target audience and the business value you're thinking for this.
Yeah.
Yeah. So as I was talking about the motivation earlier for me is, it's really about treating virtual machines as Docker containers and simplifying the creation, start, stop, performance of that, and using those in place of other places where you may actually use real hardware or cloud resources or whatnot. So for me, that's the motivation around when I'm working on the WKP product, right? I'm trying to build larger Kubernetes clusters in order to get my hands on all those either virtual machines or using cloud resources is going to be expensive. It's going to be time consuming. So for me, it's a lot around the testing aspect, testing turnaround time, and being able to do, like I said, kind of that catastrophic failures and say, okay, well, how long would it take WKP to build a 100-node Kubernetes cluster, right? And by the fact that I can spin up those virtual machines like that, and then I can use kubeadm on it to build, install whatever I need, and then join the cluster. Okay, now I have something that's a repeatable process. And by the way, it's all in GitOps, and I can run it all directly from that as well. So that's my motivation. It's not to replace the Docker desktop. In those aspects, it's more around let's get VMs to be more immutable and easier to interact and use. That would be my answer.
It's a good answer.
Okay.
Yeah. The other way to think about Ignite is just like, what if you built VMs in the same landscape as all of these other container tools? Because other tools weren't built with that same ecosystem. So.
Cool. Thanks for jumping up here, by the way, and helping out with the questions.
Yeah,
Chris.
Awesome. Thank you so much, Mark. Maybe you can answer some more questions after, if you're interested.
Yeah, if you have other questions, grab me afterwards, grab Lee afterwards, or swing by the Weaveworks booth. I'm there, and Lucas, who created a lot of this, is sometimes around the booth, and he might be able to answer some questions as well. Thanks, everybody.